Is there a number that when squared is negative? If so, what number system does it belong to? In this lesson, you will explore the characteristics of the real number system by using a Venn diagram. Let's start by reviewing the natural numbers. Both 5 and 21 are examples of natural numbers, and we can say that the set of natural numbers starts at 1 and we can count up. Therefore, we can define the natural numbers as the counting numbers. Then we have the whole numbers. Some examples of whole numbers are 2, 9, and 37, which are also natural numbers. So all the natural numbers are whole numbers. There's just one number that isn't included in the set of natural numbers, but is included in the set of whole numbers, and that number is 0, which is why we can define whole numbers as the set of counting numbers and 0. Next are integers. Some examples of integers are 3 and 17, which we know are the natural numbers. 0 is also an integer, which means the whole numbers are integers. We can also include numbers like -17, -3, and -1. Notice there are no fractions or decimals in our Venn diagram yet. We can define the integers as the whole numbers and their opposites. We can then talk about rational numbers. Natural numbers, whole numbers, and integers are subsets of the rational numbers, which means they're all included in the set of rational numbers. But we can also include a few more examples. 3.5 is a rational number, -10/11ths, and 0.1 repeating are all rational numbers. We can define rational numbers as any number that can be written as a fraction. Take a look at 3.5. 3.5 can be written as a fraction because we can read that as 3 5/10 or 3 1/2. 3.5 is an example of a terminating decimal. Next, we can look at the next decimal, 0.1 repeating. Any repeating decimal can be written as a fraction as well, and this can be written as 1/9. All of the natural numbers, whole numbers, and integers can also be written as a fraction by putting 1 as the denominator. Let's talk about the real number system. There's one more type of number that we need to include with natural numbers, whole numbers, integers, and rational numbers. One example would be pi, 3.141592653589979, and so on. This number is very irrational because the decimal does not repeat and does not terminate. Pi is the most common example of an irrational number. Another common example of an irrational number is the square root of a non-perfect square. The square root of 2, for example, is equal to 1.414213, and so on. So the square root of 2 is an example of an irrational number. We can define an irrational number as any non-repeating, non-terminating decimal. So all 5 of these sets now make up the real number system. So is there a number that when squared is negative? Let's try a couple of numbers from the natural number system. Let's take 1 squared, and we can separate it as 1 times 1, which we know is equal to 1. So we see that 1 squared is greater than 0, but instead of reading that as 1 squared is greater than 0, we can say 1 squared is positive. The notation greater than 0 can be read as is positive. Let's see another example, 6 squared. Again, 6 squared is equal to 6 times 6, which equals 36. So the same holds true, that when you square a positive number, we get a positive result. Let's try a couple of integers. Before we do that, we need to look at a common misunderstanding. -5 squared is not equal to -5 in parentheses squared. -5 squared can be rewritten as -1 times 5 squared. And by using the order of operations, we would perform 5 squared first, before multiplying. So we would get -1 times 25, which equals -25. Now if we simplify -5 in parentheses squared, that would equal -5 times -5, which is equal to +25. Therefore, -25 is not equal to +25, and so -5 squared is not the same as -5 in parentheses squared. Parentheses do matter when squaring integers. So back to the guided practice, let's try another integer. Let's square -9. So -9 squared is equal to -9 times -9, which is equal to +81. So -9 squared is also positive. Let's try a couple of numbers from the rational number system. 5/8 squared is equal to 5/8 times 5/8. When you multiply fractions, you multiply numerator by numerator and denominator by denominator. Essentially, you multiply across. So we get a result of 25/64. That number is still positive. One more example, -4/5 squared. We also get a positive result because a negative times a negative is always going to be positive. So is there a number that when squared is negative? The examples that we looked at today can be broken up into 2 sets. The first type is a positive number squared. When you square a positive number, it's equal to a positive times a positive, which equals a positive. When you square a negative number, a negative times a negative is also equal to a positive number. Therefore, it is impossible to square a real number and get a negative number as a result. In this lesson, you have explored the characteristics of the real number system by using a Venn diagram and finding products.